annotations or metadata. Java's JDK version 5 supports a special feature that enables the user to embed supplemental information into a source file, and this is called as annotation or metadata. Annotations does not change the actions of a program, thus leaving the semantics of the program unchanged. Annotations can also be used by various tools during both development and deployment. Annotations may be processed by a source code generator. Annotation Basics. An annotation is created through interface. Let's see how to declare an annotation. Here is an example of declaring an annotation by an. First, notice the @ symbol that precedes the keyword interface. So here we have the declaration of annotation my anno. Observe this @ symbol that precedes the keyword interface. This @ symbol actually tells the compiler that an annotation type is being declared. The name of that annotation is my anno. Next, also notice that there are two members, str and var. These are the two members that are being declared within the annotation my anno. All annotation consists solely of method declaration, that is, you need not provide bodies for these methods, as Java implements these methods for us automatically. Moreover, these methods act much like fields. We'll see this shortly. An annotation cannot include an extends clause, although all annotation types automatically extend the annotation interface. Thus, we can say that annotation is a super interface of all annotations. It is declared within the java.lang.annotation package. It overrides hash code, equals, and toString, which are defined by the object. It also specifies annotation type, which returns a class object that represents the annotation. Once an annotation is being declared, it can be used to annotate. That is, any type of declaration can also have an annotation associated with it. For example, classes, methods, fields, parameters, and enumeration constants can be annotated. Even an annotation can be annotated. In all these cases, the annotation precedes the rest of the declaration. When an annotation is being applied, we need to give values to its members. We will understand this with the code snippet. Here is an example code snippet where annotation my anno is being applied to a method declaration my method. This annotation is declared with the method my method, and the name of the annotation, that is my anno, is preceded by an @ symbol and is followed by a parenthesized list of member initialization. Suppose we want to give values to members, then that member's name is assigned a value. So if we see in this example, the string annotation example is being assigned to this str member, and an integer value 100 is assigned to the val member of my annotation respectively. Also notice that no parentheses follow str and value in this assignment. When an annotation member is given a value, only its name is used. Thus, annotation members str and val look like fields in this context. Specifying a retention policy. Before exploring more on annotations, we need to know what is annotation retention policies. A retention policy is that which determines at what point an annotation is to be discarded. Java defines three such retention policies, which are encapsulated within the java.lang.annotation.retention policy enumeration. This enumeration consists of three enumeration constants, that represents the retention policies. They are source, class, and runtime. So we will look into each of these retention policies. First retention policy is source. An annotation with the retention policy of source is retained only in the source file and is discarded during compilation. Second retention policy is class. An annotation with the retention policy of class is stored in a .class file during compilation. However, it is not available through the JVM during runtime. The third retention policy is runtime. An annotation with retention policy of runtime is stored in the .class file during compilation and is available through the JVM during runtime. Thus, runtime retention offers greatest annotation persistence. A retention policy is specified for an annotation by using one of the Java's built-in annotations, that is, @retention. Its general form is as shown: @retention of retention policy. Here, retention policy must be one of the previously discussed enumeration constants, that is, source, class, or runtime. No retention policy is specified for an annotation, then the default policy of class will be used. The following version of MyAnno uses a retention policy to uses @retention to specify the runtime retention policy. Thus, MyAnno will be available to the JVM during program execution. Obtaining annotations at runtime by use of reflection. Although annotations are designed mostly for use by other development or deployment tools, if they specify a retention policy of runtime, then they can be queried at runtime by any Java program through the use of reflection. Reflection is nothing but a feature that enables information about a class to be obtained at runtime. The reflection API is contained in the java.lang.reflect package. Now, we will walk through an example program that applies to annotations. The first step to use reflection is to obtain a class object that represents a class whose annotations we want to obtain. Class is one of Java's built-in classes and is defined in java.lang. There are various ways to obtain a class object. One of the easiest is to call the getClass method, which is a method defining object. Its general form is as shown here. Final class getClass. It returns a class object that represents the invoking object. After obtaining a class object, we can use its methods to obtain information about the various items declared by the class, including its annotations. To obtain the annotations associated with a specific item declared within a class, we must first obtain an object that represents that item. The item may be a method, field, or constructor. For example, class supplies the get method, get field, and get constructor methods, which obtain information about a method, field, and constructor respectively. These methods return objects of type method, field, and constructor. Let's take an example that obtains the annotation associated with the method. To do this, first we must obtain a class object that represents the class and then call the get method on that class object, specifying the name of the method. The get method has the following general form: method get method of string, method name, class, parameter types. The name of the method is passed in method name. If the method has arguments, then class objects representing those types must also be specified by param types. Here, param types is a whereas parameter, which means that we can specify as many parameter types as needed, including 0. The get method returns a method object that represents the method. If the method cannot be found, no such method exception will be true. From a class, method, field or constructor object, we can obtain a specific annotation associated with that object by calling the get annotation method. That is, the third thing is we must obtain a specific annotation associated with the object. And this is done by calling the get annotation method. Its general form is as follows. A extends annotation, get annotation of class annotype. Here, annotype is a class object that represents the annotation in which we are interested. The method returns a reference to the annotation. Using that particular reference, we can obtain the values associated with the annotation members. The method returns null if the annotation is not found, which will be the case in the if the annotation does not have the runtime retention. Here is a program that uses reflection to display the annotation associated with a method. This program uses reflection to obtain and display the values of str and value val in the myAnno annotation associated with the myMeth method in the meta class. Two things to be paid special attention in this program is this line. First is this line myAnno equals m dot get annotation of myAnno dot class. Notice the expression myAnno dot class. This particular expression evaluates to a class object of type myAnno. The annotation. This construct is called a class literal. We can use this type of expression whenever a class object of a known class is needed. That is, this statement could have also been used to obtain class object for meta class like this. Class C equals meta.class. This approach only works when we know the class name of an object in advance, which might not always be the case. In general, we can obtain a class literal for classes, interfaces, primitive types, and arrays. The second point of interest is the way the values associated with str and val are obtained when they are output by the following line. This particular line. System.out.println of anno.str, anno.val. Notice that they are invoked using the method call syntax. The same approach is used whenever the value of an annotation member is required. So here, when assigning values, we had not been using the parentheses, but while trying to display the values, we are using the method call syntax. That is, we have the parenthesis. Second reflection example. The preceding example, method had no parameters. As a result, when get method was being called, only the name myMeth was being passed. However, if we want to obtain a method that has parameters, we must specify class objects that represent the types of those parameters as arguments to the method get method. For example, here is a slightly different version of the preceding program. In this particular version, MyMath takes a string and a integer parameter. So here I have a MyMath method being defined. It takes two parameters, one of type string and the second parameter of type int. In this particular version, we have seen that it takes two parameters. We can obtain the information about this method MyMath by calling the get method as shown. Here I have invoked the get method and passed the parameters to it. So one among the parameter is name of the method myMath. Here the class objects that represents string and int are being passed as additional parameters. So if you observe this line which invokes the get method, I have passed three parameters. The first one is the name of the method, that is myMath, which takes two parameters, one of type str and type one of type string and the second type of integer. So I had taken three parameters. So these are, that is the second and third parameters are the additional parameters that are being passed to the get method. Obtaining all annotations. We can also obtain all annotations that have runtime retention that are associated with an item by calling the get annotations method on that particular item. For this, let us take an example. So here is a program that shows all annotations for a class and a method. The get annotations general form is annotations get annotations. This returns an array of annotations. The get annotations method can be called on objects of type class, method, constructor, and field among others. This is an reflection example that shows how to obtain all annotations associated with a class and with a method. It declares two annotations, myAnno and what. So here I have declared two annotations. One is named as myAnno and the second annotation named as what. These annotations are used to annotate a class, meta2, and a method meth. So I have used these annotations myAnno and what to annotate a class called meta2 and a method myMeth. This program uses get annotation method to obtain an array of all annotations associated with meta2 class and with the myMeth method. The get annotations method returns an array of annotation objects. Here we can recall that annotation is a super interface of all annotation interfaces and that it overrides toString method in object. Thus, when a reference to an annotation is output, its toString method is called to generate a string that describes the annotation. So here I have used the get annotation method on the get class, and this is used to display all annotations of the myMeth method. We can see an array of all annotations associated with the meta2 class and the myMeth method in the following output. So these are the annotations that are associated with the meta2 class, and these are the annotations that are associated with the myMeth method.
conclude, we'll summarize the topics discussed. In this video lecture, we have briefed about annotations, wherein we learned that annotation is a small comment or a form of metadata that provides data about a program. Next, annotation basics. Here, we have learned how an annotation is created through an interface and how to annotate a method. The next topic, that is specifying a retention policy, we have learned that retention policy is that which determines at what point an annotation is to be discarded. Also, we have very precisely discussed about three retention policies. They are source, class, and runtime. Next, in obtaining annotations at runtime by use of reflection. Here we have learned how to use reflection to obtain information about a class at runtime. Also, we come to know the usage of methods like getClass, getMethod, getConstructor, and getField, through which we can obtain information about a class, method, field, and constructor respectively. Next, a second reflection example. In this example, we have the annotated method myMeth being used that takes a string and int parameter, and also the get method is being used to obtain information about the myMeth method. Lastly, obtaining all annotations. To obtain information about all annotations in a program, we have used the get annotations method, which returns an array of annotations. In the next video lecture, we will know about annotated element interface using default values, marker annotations, single member annotations, built-in annotations, and some restrictions that are applicable on annotation.